Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. The first identity we're going to look at is sine squared x plus cos squared x equals 1. This is really important identity that you need to know, learn and memorise. There's a little saying that will help you remember it. So if I was sine squared and you were cos squared, together we'd be 1. So that should help you remember this little identity. Now the identity is really important because you need to use it when you're solving trig functions, when you're proving, when you're integrating. It can be used in so many different ways. And a good form of remembering is cos x is equal to the square root of 1 minus sine squared x. And also sine x is the square root of 1 minus cos squared x. There are two rearrangements of this formula which are very useful sometimes when you have to solve equations later on when they get quite challenging. So have a remember of these ones. They're just different orders of the equation sine squared x plus cos squared x equals 1. But this is a really key formula. Make sure you learn it. The next identity is tan squared x plus 1 is equal to sec squared x. Again, this is really important identity and you are likely to have to use it in your exam. Now, to help you remember this identity, if we take the identity we've just looked at, sine squared x plus cos squared x is equal to 1, if you divide each of these three terms by cos squared x, you will end up with this identity here because sine squared x divided by cos squared x gives me tan squared x. Cos squared x divided by cos squared x gives me 1. And 1 divided by cos squared x is the same as sec squared x. So this is where this identity comes from. Now the most important form of this identity is writing it in the way tan squared x is equal to sec squared x minus 1. Now the reason this is important is because I can integrate sec squared x minus 1. But it's hard to integrate tan squared x without using this identity. So this is why this identity is really important. So when you have to integrate it, you have to rearrange it to get tan squared x. Then if you write it as sec squared x minus 1, you will be able to integrate it. If you see my video on integration, that will tell you the steps to be able to integrate tan squared x in more detail. But this is a really important identity, so make sure you learn that tan squared x plus 1 is equal to sec squared x, or remember how to create it from the identity sine squared x plus cos squared x equals 1. Another identity you'll be expected to know is the identity 1 plus cos squared x is equal to cosec squared x. Now this one is also generated from the identity sine squared x plus cos squared x is equal to 1. So if I take each of these terms and this time divide each of them by sine squared x divided by sine squared x gives me the 1. Cos squared x divided by sine squared x gives me the cot squared x, because sine squared divided by cos squared is tan squared, and 1 over tan squared is cot squared. And then I've got 1 divided by sine squared x, which is cosec squared x. Again, another important identity that you'll be expected to either know or how to work out. Now the next identity is tan x is equal to sine x divided by cos x. Now I like to remember this identity, to remember whether it's the sine or the cos on the top. The S stands for the sun. So to get a tan, on the beach, you need the sun high up in the sky in order to be able to get a suntan. So the S goes at the top. So that's how I remember that tan x is sine x divided by cos x. There are other ways to help you remember it, but that's just one little way. But it's a very key, important formula that you need to learn. Now the compound angle formulae are given in your formula book, and it says of sine of A plus or minus B is equal to sine A cos B plus or minus cos A sine B. Now what this means is I look along the top, so the top signs go together, so the two pluses here go together, or the two minuses come together, depending on what you've been given. So sine of A plus B is equal to sine of A cos B plus the cos A sine B, or sine of A minus B is equal to sine A cos B minus cos A sine B. Now this formula is used, and it's really useful in order to be able to calculate the double angle formulae. So if you let A equal to x and B equal to x, I end up with x plus x, which gives me 2x. I've got sine x cos x plus cos x sine x, which is two lots of sine x cos x. So the double angle formula, which is used a lot in the exam, can be created from the formula that is given in your formula book of the compound angle formula. Now, I would recommend you learn this because even though you can calculate it, in the exam you're going to be always pushed to make sure you've got most time possible. So as long as you recognise them, it will help you out in the exam if you know them, rather than having to work them out every single time. The next compound angle formula is for the cos. So cos of A plus B is equal to cos of A, cos of B minus sine of A, sine of B. So this time the ones at the top, the plus on this side and the minus go together. And alternatively, the other way around is cos of A minus B is cos A, cos B plus sine A, sine B. So you've got to be careful with the signs because this is a plus or minus and then this one is a minus or plus. Again, this compound angle formula will be given to you in your formula book. Now from this compound angle formula, we can create the double angle formula for cos 2x. So the first one here, if I replace A and B both with x, I get cos of x plus x, which is cos of 2x. So cos of x is cos squared x. Sine of x is going to be sine squared of x, which is where cos 2x is equal to cos squared x minus sine squared x comes from. The one in the blue is going to be given to you in the formula book. The one in yellow, I would recommend you learn these because it is going to be time saving in the exam. You can work them out in the exam if you do forget or you want to just check. Now from here, the first identity we looked at was sine squared x plus cos squared x is equal to 1. Now if you take this formula, okay, and replace the cos squared x with 1 minus sine squared x, I end up with 1 minus 2 sine squared x. Now this is a really important way of writing it, okay, so cos 2x is equal to 1 minus 2 sine squared x. This form here is going to be much more important and useful for you than the top form. The top form can be generated from the blue formula in the formula book, and then using the first formula that we learnt, you can create this new formula, cos 2x is equal to 1 minus sine squared x. Now if I go back to this initial formula here of cos 2x, and this time replace the sine squared x with 1 minus cos squared x, I'm going to end up with a minus 1 on the end, and then I've got a minus times the minus cos squared, so two minuses become a positive, which is why I've got a cos squared x plus a cos squared x, which is going to give me 2 cos squared x minus 1 for cos 2x. These bottom two formula here are really important that you learn them in this form. Okay, so make sure you know your double angle formulae, because if you don't spot them, then you're not going to be able to use them in the exam. Now, the rearrangement of this the middle formula here in the yellow star, okay, I could rearrange this to give me sine squared x is equal to a half 1 minus cos 2x. So from this middle formula here, I can rearrange to give me the value of sine squared x. Now, this formula here is really important when we come to integration. We could do a similar thing here for the cos squared. So I can rearrange this by adding 1 to both sides, divided by 2, gives me cos squared x is a half of 1 plus cos 2x. These two formulas are really important when it comes to integrate. So you've seen my video on integration. I will show you how to integrate sine squared x and cos squared x, but the rearrangement of them into this form here is really important. So I recommend you learn the version in the red star because it will save you a lot of time in the exam. If you recognize this, when it comes to the exam, it will save you a lot of time having to work them out. The last of the compound angle formula is tan of A plus or minus B is equal to tan of A plus or minus tan of B over 1 minus plus tan of A, tan of B, which means tan of A plus B is the same as tan of A plus the tan of B divided by the 1 minus the tan A, tan B. So you've got to use all the ones at the top, the signs at the top. If I was going to do subtract, I've got tan of A minus B is tan of A minus tan of B, all divided by 1 plus tan of A, tan of B. So it's really important that you write these formulas out using your pluses and minuses, and be careful which way round the pluses and the minuses go. From here, I can replace A and B both with X to create a double angle formula. So if tan of X plus X is equal to tan of 2X, it's going to be tan of X plus tan of X, which is 2 tan of X, all divided by 1 minus tan X times by tan X, which is tan squared of X. So it's really important that you know how to create the double angle formula from your compound angle formula that will be given in the exam. But it is worth learning the form of what they look like, so in the exam you are quicker at spotting when to use these identities. You also need to know the small angle formula. These are also given in your formula book. So sine of theta is approximately equal to theta, and this will be working in radians. Now, if you see in the question it says the word small angles, it will always give you a clue by saying the word small angles. You need to use sine theta is approximately equal to theta. So whenever you see the term sine theta, you just replace it with theta. Similarly, you can do the same for cos theta and for tan theta, and I'll give you the identities for those shortly. So the identity for cos theta with small angles is cos theta is approximately equal to 1 minus theta squared over 2, and again where theta is in radians. So again, in the question, if you see the word small angles, you replace any cos theta that you've written down in the question with 1 minus theta squared over 2. It will make your calculation much simpler to work with. The last small angle formula is tan theta is approximately equal to theta. Now again, when you see the word small angles, you need to remember to look in your formula book, and when you see the term tan theta, you will replace it with theta. Remember, the sine theta and tan theta are exactly the same. They're both equal to theta, and this only works when we're in radians. Now, if you've liked this video and you want to see more, please comment below to let me know what you would like to see in my next video. Remember to like and subscribe so we can all get great at maths together. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!